Welcome to Spring LIB.
All right, so for part A, we're gonna define x to be the distance between the center to an element with length dx. Okay, and then L will be the length of the propeller. Therefore, v, velocity of at volume element dx, will be x times omega, right? R times omega, and therefore from EMF equals b times length times magnetic field strength times length times velocity, we have EMF equals b times L we have dE, d epsilon, or incremental EMF is equal to b times x omega times dx, because dx will be this L, the small l here. Therefore, we can integrate the EMF from 0 to L over 2, half the length of the propeller. And so that's the integral of bx omega dx. And this comes out to be omega b L squared over 8. So that's your EMF for part 1, or part A. In part B, EMF will be 0 volts because it's the same at both ends. And finally, in part C, we're plugging in values now, plugging into values into the answer from part A. And so EMF is omega b L squared over 8, right? So this is omega, which is 220 revolutions per minute, times pi over 30 radians per second, times 0.5 times 10 to the negative 4 Tesla, times 2 meters quantity squared, all divided by 8. And this comes out to 5.8 times 10 to the negative 4 volts, or 0.58 millivolts. And that's it.